If the exhaust gas is hot enough, combustion of remaining hydrocarbons and carbon monoxide can be completed by adding extra air to them at the exhaust port or manifold. This afterburning produces water and carbon dioxide, which are then exhausted to the atmosphere. The pulse air method uses the pulsations of the exhaust gas to open and close a reed valve. It admits air into the exhaust manifold in short bursts. Air drawn from the air filter enters the exhaust manifold. This method suits engines with 4 cylinders or less because their exhaust pulsations are further apart. Larger capacity engines may use an air pump to supply a larger volume of air. The pump is normally driven by a V-belt from the engine crankshaft and forces air into the exhaust ports. Some of the engine's output is used in driving the pump. Electronic fuel injection and engine management systems deal with emissions more effectively than carbureted engines by more closely controlling the air-fuel ratio entering each cylinder and by ensuring the ignition timing matches operating conditions. Sensors around the engine send the ECU information about airflow, coolant temperature, throttle position and engine speed. The ECU uses this to set fuel and ignition settings from its programmed memory. Most systems also use a sensor in the exhaust manifold to gauge the amount of oxygen in the exhaust gases leaving the engine. This indicates how well combustion is being completed, which in turn indicates the air-fuel mixture entering the engine. A voltage signal is then relayed back to the control unit to indicate whether the mixture is rich or lean. More oxygen indicates a lean mixture. Less indicates a rich mixture. The control unit then adjusts the amount of fuel being injected into the engine to keep the air-fuel ratio very close to the chemically correct composition for complete combustion. By mass, this is 14.7 parts of air to 1 of fuel, known as the stoichiometric ratio.